First slide, please. Next slide. I'm Mike Rosenberg. I'm the CEO of Prieto Battery. Prieto is an advanced lithium-ion battery company. We're developing a advanced 3D rechargeable battery that addresses all the shortcomings of traditional lithium-ion batteries. Next slide. Lithium-ion batteries today are pretty good, but there's still significant issues, particularly in the electric vehicle space. If we want to move to a complete transformation of the auto industry to electric, we need batteries that provide better range, can fast charge, that are safer, that can operate at minus 30 degrees, start up and work. And they need to be lower cost so you can have batteries and long range in vehicles that are lower priced. Next slide, please. Typical batteries are 2D type structures. They're layered like pancakes. And you typically have to make a choice in whether you're going to have long range, high energy density, so you make your anode and cathode very thick, or you have to make a battery that's fast charging, so you make your anode and cathode very thin, so the lithium ion doesn't have to transfer very far. We've taken a different approach. We've decided to do a 3D interdigitated battery that allows you to have both high energy density and fast charging in the same battery. Next slide. Now, 3D batteries have been around for a long time. People have made them in the lab, but never been able to manufacture them. So when Amy Prieto started this company, she said, okay, if I'm going to do this battery, I need to be able to manufacture it. So she started with manufacturing in mind at the beginning. And what she did is she looked at manufacturing processes and took out anything that was going to be high cost. So she wasn't going to use any clean rooms or dry rooms, nothing that required, 2000 degrees centigrade temperatures, nothing that required hazardous solvents or exotic chemicals or high price chemicals. So what she came back to was deciding on using electroplating as her main manufacturing process. And then with that in mind, she then went and said, okay, what does my battery need to be made of to be able to make this work? And that's how she decided on the different materials that we're using within our battery. Next slide. The easiest way to understand our batteries, so let's take a look at this picture. We start with a copper foam, which has an enormous amount of surface area per given footprint. That allows you to get a lot of anode and cathode into the battery, but we coat the little metal tentacles of the copper foam with our anode. So the copper foam acts as the tool for the electroplating of our anode on top of that. And then we put an electropolymer on top of the anode, and then we coat all that with a cathode. So what you have is a lot of energy density within this footprint, but the layers are very, very thin. So the lithium ion doesn't have to go very far, so you get fast charging out of the same battery. Next slide. We've got working prototypes now. The image in the left-hand corner is our 3D battery compared to a 2D battery. Shows that it's much higher energy density, up to 5 times higher power density, 2 to 3 times more energy density. We've operated these things down to minus 30 degrees centigrade with starting up from a frozen start. We've gotten up to 300 cycles, and they're safe. You can cut these things in half. They do not start on fire. There is no thermal runaway. So it addresses the key lithium-ion safety issue that you have today. Next slide. As I mentioned, this is electroplating. Electroplating is used extensively in the semiconductor industry. It's water-based, it's atmospheric temperature, atmospheric pressure, a room temperature, atmospheric pressure. And once you get the battery made in a reel-to-reel process, the rest of the battery manufacturing process is the same today. Slitting, calendering, welding, stacking, same thing. Next slide. We have 28 patents issued, over 7 distinct patent families covering materials, architecture, and the manufacturing process. Next slide. And we're looking to grow into or develop our process. So right now we're scaling the footprint of our battery, and we'll have that being tested in the transportation industry, auto companies, consumer industrial partners. We have 2 strategic partnerships, one with Stanley Black & Decker for power tools and one with Hercules Electric Vehicles for EV equipment. We'll be doing these pilot runs and testing in 2022, building a pilot plant in 22, 23, and commercializing in 25, 26. Next slide. There is competitors in this landscape. There's a number of different solid state companies that are doing things differently. I'd say the one big thing for us is we started with manufacturing in mind. So we have a low cost, high volume process already identified that we just have to modify to our process, where most other people are inventing their manufacturing process today. And there is no guarantee that they'll be able to do so. So we think we have an advantage going forward. Last slide. I'm a 25-year plus clean tech executive. Amy Prieto is well known in the battery industry. She's won the Presidential Early Career Award for Scientists in Engineering. She's got a number of different awards, and we believe we're on path to have a large working prototype next year and pilot plant by the end of 2023. With that, I'll open it up for questions. Thank you.
Can I ask a quick question to first go, if it's okay with you? Actually, I know the 3D battery has it's an innovation, and you made it actually manufacturable. It's a great idea. It's great. So I think it can be a game changer. My question is that just two quick questions here. So first, what is the lifetime of the battery? No, based on the 3D side of it. That's first question.
So the 3D, we've tested it up to 300 cycles so far, and that's 100% depth of discharge. If we do to what normal commercial charging is, like 80% of depth of discharge, then we are out to thousands of cycles. So we're continuing to improve that as we scale the battery, and we're targeting, for automotive applications, at least 1,000 cycles, which gives you, 300,000 miles.
Okay. And I know you secured 28 patents, which is great, and a lot of great intellectual property protection there.
Yep.
Are you at a liberty to work with the investors or companies overseas, or you have some restrictions on your funding, or nope? Okay.
No, there's no restrictions. We're able to work with partners overseas. Absolutely.
Overseas. Okay. All right. All right. Thank you. Okay. President, maybe you can connect later. Thank you.
Okay. Sounds great.
I have a question. About adding one more characteristic to what you've got, which is a strategy for recycling.
Yeah, our batteries are recyclable. We have not designed the battery for recycling per se, but we know that the materials that we use are easily recyclable. The copper antimony anode, that's all something that can be separated. Our separator is a traditional polymer that again can be separated out and used. I think the only challenge we have is what all lithium-ion batteries have, which is in the cathode, where you have the nickel, metal, cobalt materials that have to have a process to do so. So I think when the recycling business develops, our battery will be easily recyclable.
I have a quick question. So were you in touch with the kind of the big lithium-ion batteries player, LG Chem, Samsung SDI, or not yet?
We have had some preliminary conversations. The company's been around since 2009. We've raised $20 million to date. And I know we've had some conversations in our past. But the prototype fully 3D interdigitated battery was really available in 2020. So it was a development of last year. We've had the anode previously, but the full digital 3D battery was developed 2020. So we've got a very small battery to date, but we've already scaled it by 60x over the last 2 months. So we're pretty excited about moving forward, and we're certainly looking to have conversations with the battery manufacturers, auto companies, consumer product companies, others, as we move forward.
Do you have your own manufacturing facility?
We do not yet. Everything is lab scale to date, but because we've determined, been working with the manufacturing in mind already, we're designing that first pilot facility as we speak. So we expect to have our first design by April, May.
Okay, and in terms of the manufacturing cost, do you have kind of an estimate whether it's on par with the mass scale lithium-ion manufacturing?
It's not going to be any more than that for sure. It's electroplating. It's done at room temperature, atmospheric pressure. There's no hazardous solvents. There's no dry rooms, clean rooms. We're not handling lithium, lithium metal or anything of that nature. So the process should be simpler and lower cost, but we're doing the design now to verify that.
Okay, interesting.